Now the section that we're going to look at here is section 4.6, which is moment of a couple. And moment of a couple is kind of crazy. This is where things start to get a little nuts. Basically, the idea is that you have something kind of like a steering wheel, you know, where you've got two forces, you know, one going like this, and one going like this, and say one going like this. We'll call this one F, and this one is negative F, and they're separated by a distance D. Okay, another way to say it is, we'll just say it for that for the moment. Let me just leave it there. A couple is defined as two parallel forces with the same magnitude but opposite directions separated by some perpendicular distance D. Alright, so this is perpendicular. I was doing over here a second. That's my perpendicular distance D. Perpendicular. Alright, so that's a couple. And the only way that this works is the two forces have to be parallel, and they have to have the same magnitude, and they have to have absolutely opposite directions. And that's what we're going to assume when we talk about a couple moment. And that's a very, very important assumption, actually. So let's talk about this thing that's going on here. This guy. Alright, so I'm just going to move him down here. Whoa, he moved funny. I'll leave him where he was. He was obviously happy there. I'll just draw him again. So I've got this little guy going on here. And here's my F. And here's my minus F. Alright. Now, I'm going to arbitrarily pick a point down here, and I'll call it point O. Alright. Now, if I want to find, we'll call this point, what should I call this? I'll call this point B. And I'll call this point A. I think I'm doing this backwards. I'll call this one point A. The one that goes with the negative, I'll call it point A. Not like it matters, it's just all going to come out in the wash anyway, just so it matches my notes. From A to B. Alright, so now if we wanted to know, well, what is the moment around O, and we'll call it the moment around A. What is the moment around A? How do we find the moment around A? Well, we're going to say that, remember R cross F, so it's R. So it's R from O to A. So it's R from O to A, crossed with F, which happens to be negative F. Okay? M caused by A is R from O to A, crossed with some negative F. Alright? Now let's look at the moment around B. It's just going to be R from O to B, R from O to B, crossed with positive F, just like that, right? Alright, so that means my total moment, my resultant moment, is going to be MA plus MB, right, for the whole system. My moment resultant around O is going to be MA around O, MB around O. I left off my O's, but it doesn't really matter because we're only talking about that point right now. Alright, so let me do some messing around over here. R cross from O to A, cross with the negative F. So what can we do with that negative sign? Remember, we can pull it out front. We can go like this. This is valid. It's also valid if you want to really pull it out, R cross OA. R of OA cross F, like that. Right, that's valid to do. Alright, well, I'm going to plug that now into my resultant moment formula. So my moment around A would be negative ROA cross F. And then I'm going to add my moment around B, from O to B, ROB cross F. Alrighty. Now, for my cross product rules, I know that I can, quote, factor out an f. So I've got negative ROA plus ROB crossed with f, like that. And that's a completely legitimate step to take. I can just rewrite this crossed with f. Now the question is, what can I do to make this look better? That's got to be equal to something. That's just too pretty not to be. All right, so let's take a look again. If I have an O and an A, and this is a formula, you actually should know this, but I'm pretending you don't. Okay, so this was, what do we call this one? So I'm just consistent. That one was our A. Okay, so that's our A, and that's our B. So if I have R from O to B minus R from O to A, how are those two things related? How are they related to this? Okay, so let's talk about it. If I wanted to, so if you can't remember the formula, basically what I'm trying to show you is if you can't remember the formula, there's a way to figure it out. I say, well, if I just drew that in there, well, from here I can clearly say that R from O to A plus R from A to B is clearly equal to, if I put them tip to tail, the resultant is most clearly R from O to B. All right, so let's, for funsies, do some isolation here. So we've got, what am I actually looking for? I'm looking for ROB minus ROA. So if I subtract, I feel like I'm in college algebra. If I subtract my ROA from both sides, I get R from A to B is R from O to B minus R from O to A. Okay, so RAB is ROB minus ROA, and you should know that. Any position vector from A to B is going to be B minus A. Okay, so what I really have here is I have the same thing, ROB minus ROA, ROB minus ROA. That's R from A to B. So I can get rid of this now, and I can call this R from A to B cross F. So what happened just now? This is kind of critical. What just happened is that O is gone. So where's the O? Basically what happens is the O is gone. It doesn't matter. And that's what's neat about couple moments, is because this force was equivalent and just in the opposite direction, that allowed us to factor it out with the minus sign in there, and now all of a sudden we've got an equation for a moment that's not dependent upon a point O. So if I point that point here, if I put the point here, if I point the point here, any place that I would have placed that point would not have mattered. It still would have gone away. So this is actually a really, really, really big deal. The big deal is that actually this moment, so a moment, couple moment, I'm gonna call it couple moment. Our couple moment is a free vector. It's a free vector, okay? And this is going to be kind of hard to swallow for a while. But a couple moment is a free vector. So let me write this again, and we'll look at the picture. So we've got that our M is equal R from A to B cross F. And this is important to get the direction right. So if you look at our original picture, our A and our B was the guy who was over on the positive side. Okay, our B was over there on the positive side. So, let me do it this way. If I've got a force this way, going negative, and I got a force over here, it's my positive force, and this is my vector A to B. All right, so your moment couple is a cross product between RAB and F. And it's important to remember that RAB is going in the direction from A to B. So you want to put your wrist, if you're doing this like kind of a right-hand rulesy, your wrist goes on the A, your fingers point toward the B, and then they curl in the direction of F, So now your thumb's pointing out toward you on the page. That's the direction of your moment couple. Okay. If you cross product them, if you go RBA cross F, you're going to get the direction, the opposite direction. So you want to make sure that you're really doing these in the correct direction to get a good solution. But like I said, the O is gone. So essentially what we have is M, a couple moment M, is a free vector. And what that means is we can move it around as long as it stays in the same direction. So I'm going to write this out because it's really important. We can move it around as long as it points in the same direction. And you might say, well, that doesn't make any sense, and I refuse to accept it. Well, fine, don't accept it. But before you completely give up on it, think about a force. You know, you just have a force. You've been taking that force and moving it all over the place, right? Because I said, well, if I want this force, and I want to add it to this force, well, then I can just take this one and put them head to tail and draw the resultant. And you've been moving forces like this forever and just accepting it as pure. I mean, maybe you resisted it a while ago, but you've been doing it for a long time now. And you've just accepted the fact that you can move forces around. Well, I'm here to tell you today that you can move moments around the same way as long as they're facing the right direction. So if I've got a moment coming out at the page, so if I've got a positive K moment going on right here, it doesn't matter if it's a moment couple. I can move it here, 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 I can move it here. So that's kind of cool. It's actually pretty crazy. So a resultant of that, or a result of that, is that if I've got this one over here, and I've got, we'll pretend this is a 3 moment over here, and I've got a couple moment over here, that's supposed to be a K, and if I have a couple moment over here, like this, well, I can take it and I can move them around, and I can in fact move them right on top of each other. So if I have a 3 and a 5, I can move them on top of each other, and now instead of having a 3 and a 5, I have an 8, a positive 8. Okay? And then I can move this guy around. My 3 and my 5 are combined, and now I can move them on top of the negative 2. And now I've got a positive 6 moment. So your couple moments are kind of weird in that you can treat them just kind of like you've been treating your vectors. You can pick them up and move them around. And I'm just doing it in 2D because it's easier. But the same thing applies in 3D. I can move it toward me. I can move it back. It's a free vector. It can do whatever it feels like doing.